Some discoveries don't just change science, they rewrite the rules of reality. Like, how do you explain the unexplainable? The moment when you realize that you can never know what it's like to be a bird or an elephant. To see with its eyes or feel with its skin, the unknowable vastness between us, the unbridgeable gap between subject and object, self and other, me and you. This video explores a quantum experiment, so strange it makes seasoned scientists like me hesitate before explaining it. A phenomenon in which reality doesn't behave until it's observed. A pattern that suggests your attention might not just witness the world, but define it. What begins as pure physics quickly becomes something much more personal, and by the end of this episode, you'll discover how this one incredible observation challenges everything you thought you knew about time, existence, and yes, even God. There are two ways to understand the universe, through philosophy and through science. Philosophers have been searching for answers since the dawn of humanity, asking why we ask questions. What does it mean to exist? Is there a purpose to life? What happens after death? We ponder these big questions late at night when we can't sleep, often wondering if anyone has the answers. Scientists also ask deep questions, but their approach is different. They seek evidence and proof, formulating hypotheses that lead to testable predictions, and then designing experiments to confirm or refute them. If the results support the hypothesis, it becomes a theory, a framework for understanding the natural world that can incorporate new observations, but only if those observations fit the evidence. For example, Newton developed his theory of gravity by observing the motion of planets. Einstein built his theory of general relativity by questioning the equivalence of mass and energy. Each of these theories revolutionized our understanding of the universe and its laws. But here's where things get weird. While theories traditionally sit atop mountains of evidence, this latest one sits at the bottom of a rabbit hole. It all starts with quantum mechanics, the study of the bizarre behavior of matter at the atomic and subatomic level. Here the rules of classical mechanics no longer apply. Instead, we enter a realm where particles can be in two places at once, and where dead and alive are the same thing. In the quantum world, cats can be both dead and alive until you open the box and observe them. That's the famous Schrödinger's cat paradox, illustrating the idea that quantum objects exist in a superposition of states until measured. But the paradox isn't just about cats, it's about reality itself. What does it mean to observe? Is it the same for a human and a camera? Does a tree fall in the forest if no one's around to hear it? And who or what counts as an observer anyway? These questions have been debated for decades. However, some scientists argue that the observer effect is more than a theory. It's a fundamental aspect of nature. Consider this. You know that light travels in waves, but you also know that it behaves like a stream of particles called photons. Now, what happens when you try to measure which path a single photon takes? Your measuring device, whether a screen or a camera, will inevitably interact with the photon, changing its trajectory and therefore the outcome of the experiment. This wouldn't happen if the photon's path was predetermined. For it to make sense, we need to consider the photon as existing in a cloud of potential paths until the moment it's measured. At that point, the act of measurement collapses the wave function, forcing the photon to choose one path and one path only. If you think this is confusing, you're not alone. Quantum mechanics is notoriously tricky to grasp because it upends our intuitive notions of cause and effect. However, the observer effect goes even deeper. Physicists have found that the very act of observing a quantum system changes its properties. A classic example is the double-slit experiment. When we fire photons one at a time at a barrier with two slits, we see an interference pattern, a series of bright and dark bands. This pattern emerges because photons act as both particles and waves. As they pass through the slits, they interfere with each other, creating a wave-like pattern on the screen behind the slits. But here's the mind-bending part. If we place a detector at the slits to measure which slit each photon passes through, the interference pattern disappears. Photons no longer act like waves. They act like particles. The very act of observation changes the outcome of the experiment. So, when we say the observer effect is real, we mean that the act of observation is inseparable from the observed. We're not just looking at reality, we're participating in it. Now, I know what you're thinking. Yes, quantum mechanics is weird, but it only applies to tiny things. Reality still behaves as we expect most of the time. And that's true. Quantum effects are usually negligible at the macroscopic level, meaning they don't significantly affect everyday objects. However, physicists are increasingly finding evidence of these effects in larger and larger systems, including some biological molecules. So what started out as a curiosity about the nature of reality is becoming a pressing question. What if the observer effect isn't limited to quantum mechanics? What if the act of observing something creates the very thing we're observing? This idea might sound crazy, but consider the implications. We know that the brain plays a crucial role in shaping our perception of reality. Our senses send signals to the brain, which then interprets them as sights, sounds, smells, tastes, and textures. But what if the process goes in the other direction? What if our attention shapes reality instead of just perceiving it? Imagine a world where thoughts and intentions create the conditions they're supposed to respond to. If this sounds like science fiction, consider the work of neuroscientist Bernardo Castro, who argues that we don't see the world sees us. Casthorpe proposes that the universe responds to our conscious attention, effectively creating our own private realities. It's a radical idea, but it's not entirely without precedent. Philosophers have long debated the idea that our perceptions shape our reality. George Berkeley famously argued that to be is to be perceived, but Berkeley's idealism is usually associated with a kind of naive realism. Berkeley believed that God, or what he called the divine mind, was the ultimate source of all perceptions. Casthorpe, however, offers a more secular and more scientific take on idealism. He bases his argument on the observer effect in quantum mechanics, arguing that the same principle could apply to our conscious minds. In Casthorpe's view, our brains are like sophisticated laboratories, constantly bombarding the universe with queries. Every time we ask a question, we create the conditions to answer it. In essence, we actively participate in bringing about the reality we experience. Now, you might be skeptical, and you should be. Casthorpe's ideas go against the grain of common sense and scientific orthodoxy. But here's the thing. We can't prove him wrong. We can't design an experiment that shows the universe doesn't respond to our conscious attention. Indeed, such an experiment would require that experiment to exist independently of our attention, which is exactly what Casthorpe denied. This isn't a scientific dead end. However, it's an opportunity to explore new questions about perception, time, and existence. Consider, for example, the implications for free will. If our actions shape our reality, then we have a much greater degree of control over our lives than we might think. Casthorpe's ideas also raise new questions about the nature of time. If the universe responds to our conscious attention, then time may not be a universal constant, but a malleable substance that can be shaped by our thoughts and intentions. Finally, Casthorpe's view opens up new possibilities for understanding consciousness itself. If we're not just passive observers of reality, but active participants, then consciousness might not be a property of the brain, but a fundamental aspect of the universe. We might not be separate from the universe, but an integral part of it. Here's the thing. We don't need to believe in Castropi's ideas to find them intriguing. We can acknowledge the limitations of our current understanding of reality and remain open to new possibilities. This is what science is ultimately about. Not about having all the answers, but about asking the right questions. If you found this video thought-provoking, please show your support by liking and sharing. Subscribe to my channel to stay updated on my latest videos exploring the mysteries of the universe. Together, we can unravel the secrets of the cosmos and deepen our understanding of the world around us and the universe within. Thanks for watching. Keep questioning, and I'll see you in the next video.